Yes, light exerts a tiny amount of pressure when it interacts with matter. This phenomenon is known as radiation pressure or solar pressure. It arises from the transfer of momentum from photons, particles of light, to the surface of an object. According to classical physics, the pressure exerted by light can be understood using the concept of conservation of momentum. When a photon is absorbed or reflected by an object, it imparts momentum to that object. The change in momentum per unit time results in a force, and when this force is distributed over the area of the object, it gives rise to pressure. The magnitude of the pressure exerted by light is very small. It is given by the equation P equals 2I c, where P is the pressure, I is the intensity of the light, and c is the speed of light. Since the intensity of visible light is typically on the order of watts per square meter and the speed of light is about 3 times 10 to the 8 meters per second, the resulting pressure is extremely low. In everyday situations, the pressure of light is negligible compared to other forces acting on objects. However, in specialized circumstances such as laser cooling and optical trapping, radiation pressure can be precisely controlled and utilized for various scientific and technological applications.